Now, what is a nitrogen? Nitrogen is a diatomic gas. No? This is okay. We do have a container. It's a diatomic gas. Let me give. There's a imagination what you should have this one. Whenever you say nitrogen, it's telling like contains 1.4 grams of nitrogen. That one. So can we calculate the number of molecules of nitrogen or number of moles? What all information is we can calculate that one, because we know mass, we know molecular mass of that. Total mass of gas we know, molecular mass we know. So with that we can calculate the number of moles. What is the volume of the gas? It is 5 liter volume of container. Temperature is T. It is a temperature. It's telling now it will have some pressure. Now 30% of molecules are dissociated into atoms. 30% are dissociated into atoms. What do you mean by atoms here? So can we, anybody, can you tell how many number of moles?
Point
Yes,
one
0.1 molar
in total, sir.
initially.
Yes, sir.
Okay, and one. Okay, this will be mass of gas by number of moles by molecular mass. So mass of gas by molecular mass. I think there's a formula. Can you remember this? These things. What is the mass of gas? 1.4 gram. Molecular mass of nitrogen?
14, sir.
14. Okay.
28.
Diatomic 28. Monatomic will be 14.
Okay, sir.
How much shall I write? This will be 0.05.
Yes, sir.
Okay, 0.05 moles of this one is there, of which 30% will undergo dissociation. So therefore, 30% will break up. Now, just for your understanding, I'm giving the pictorial thing from where this, because some gas molecules will break up, no? So we will get a nitrogen atoms. This will be a nitrogen molecule. So what is this? This one, nitrogen molecule. And what is this? This is a nitrogen atoms. Is asking what is the pressure. So initially, okay, let's directly get into this one. So what is the pressure? Final pressure is asking. So what all the pressure will be due to diatomic gas molecules colliding with the wall, and also nitrogen atoms colliding with the wall. Means nitrogen molecule will collide with the wall. Even the nitrogen atoms will collide with it. Due to that, there is a pressure. So according to Dalton's laws of partial pressure, the total pressure should be sum of pressure due to diatomic plus sum of pressure due to P1, P2 will write it. P1 is due to purely the one which has undergone dissociation due to atoms, nitrogen atoms, or we'll write it, atoms. Due to, so due to atoms, so do we know, can we calculate the number of atoms that are undergone dissociation? %30 of this. So one nitrogen molecule, if it breaks up, how many atoms will get it? 2, no? Shall we take it like this? So 0.05, 30% of that you calculate. or okay, there's a one thing, or we can also do one thing. So let it be, I'll come in another way. Okay, we have number of moles. So initial number of molecules, this should be equal to mass by molecular mass into Avogadro number. So what is this? Number of molecules of nitrogen. Number of molecules of nitrogen, that one. Next, what we get? Number of nitrogen atoms. So eta is what? 30%. So how many nitrogen atoms I should get it here now? Mass into eta. And mass of the nitrogen molecules, how much it will be? M minus eta. So mass of nitrogen atoms, M into eta. Mass of nitrogen molecules. So should be M minus M eta. Okay, let's go for Dalton's laws of partial pressure. So according to this, what we write? Number of moles of the atom, N1 RT by V, N2 RT by V. So what is the mass of nitrogen atoms? M into eta. Molecular mass of this will be M0 by 2. What is the mass of nitrogen, remaining nitrogen molecules? M into eta. Okay, this is not N, it is eta. M into eta RT by V. What is the molecular mass of this? This is M0. So substitute all this. Eta 30% no, so you should write 0.3. You'll get the pressure. Oh, why M0 by 2? Because nitrogen molecule, if it is having 28 gram, the nitrogen atom, half of it should be 14. You do calculation later on. Let me write it. 1.9 atmosphere. Dissociation means the molecule breaking up into atoms. I'll give one more. This will help you a lot. Okay, there are two gases are there. So let me take the nitrogen, 10 moles, hydrogen, 14 moles. They are at temperature. Let V be the volume of this. Okay, now I'll supply some heat, of which what will happen? 6 moles of nitrogen will dissociate. N1, let me take N2. On supplying heat, 6 moles of nitrogen and 3 moles of hydrogen undergo dissociation. Find the final pressure. Okay, this one, and heat to be supplied. Okay, now initially, so these are the 10 moles of nitrogen. No? Okay, let me give a very good diagram based 6 over. No? Count it 4, 4, 8, 9, 10. The hydrogen, I'll show 14. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Are you able to count it? Red and blue color. So what do this? Hydrogen, hydrogen molecule, and this is okay. We'll supply some heat. So because of that, now what will happen? It will undergo dissociation. And after dissociation, the same container volume will not change. It will be there as it is. You write it clearly. Temperature will not change. Let it be T. Okay, now let's see that. How many? 6 moles of nitrogen. On supplying it, 6 moles of nitrogen will undergo dissociation. So how many will remain as it is? 4 as it is. Okay, 6 moles will break up. How many these bubbles I should put it? 12. Okay, now hydrogen. Hydrogen, how many there? 3 moles of hydrogen. Out of 14, 3 got dissociated. So remaining 11 as it is, I have to show it. 4, 5, 6, 7, 8, 9. 4, 4. Check it, is it 11? Red color dumbbells. 5. I think I
12.
12, 11 are there. So how many 3 are there? No? So 6 bubbles is what I have to show. It's very systematic way you're learning it. Okay, now I'm asking, what is the final pressure? What is this pressure will be? This P has to be calculated. So therefore, what should be the our equation? Should be like this, no? Pressure due to nitrogen atom pressure due to nitrogen molecule, pressure due to hydrogen atom plus pressure due to hydrogen molecule. Let's see that pressure due to nitrogen atom. How many moles of nitrogen atoms are there? 6 moles. 12 are there, no? So 12. Nitrogen atom, what is molecular mass? 14, shall we write? RT by V. How many nitrogen molecules will be left over?
4.
4, sir.
4 will be left over. So 4 into, this will be 28 RT by V. Hydrogen atom. 6, 6.
6,
Yeah.
sir.
Now what should be the molecular mass of hydrogen atom?
2, sir.
2,
1, sir. Atom
1. Hydrogen atom will be 1. This will be 11
by 2.
by 2. Okay, finish. Able to make it out? This will be okay. Now I'll ask you some questions like, what happened the degree of freedom? Yes, it has changed, no? So like this, after solving this, we'll get the pressure. What is this? Pressure of mixture. Okay, after this, it's asking what amount of heat is supplied. So initial intensity of the gas, let it be UI. I have final intensity of the gas, let it be UF. So what is UI? We'll calculate. So N1 F1 RT by 2. N2 F2 RT by 2. Can you remember this formula? So N1 number of moles of nitrogen, 10, degree of freedom 5 RT by 2. This is 14, degree of freedom 5 RT by 2. This will be 25 RT,
Sir,
35.
12 by Sir, they you wrote 12 by 14 and all that now, so that shouldn't come now, sir, because they gave moles only.
PV equal to nRT, no?
Yes, sir.
Okay, this molecular mass need not know nRT. Mass means okay, we will come. Okay, this is not needed. Huh? Okay, I think I thought mass. Huh? Mass of gas come, then molecular mass will come into picture. Huh? Okay, we'll have this much here. Okay, this is a 2735, so 30, this will be 50, 60 RT. This is the initial internal energy. No, final internal energy, how much it should be? N1, I think I can't write similar, directly let me write. So number of moles of hydrogen, nitrogen atoms, 12, degree of freedom, 3 RT. So remaining how much will be there? 6 moles of nitrogen, 4 will be left over, no? 4 and diatomic 5 RT by 2. So this is for nitrogen. For the hydrogen, six into 3R by 2. So remaining 11 into. I try to see this. What is this? NF orbital. So number of like a nitrogen atoms, 12 nitrogen atoms are there. What is a monatomic gas degree of freedom? 3, no? So 3, I'll write it in place of F. Similarly, how many leftover nitrogen molecules? 6 will undergo dissociation. So 4 will be left over. So what is the degree of freedom of diatomic gas? Should be 5. So that 5 I'm substituting. The same thing for the hydrogen. Solving this, so this will be 618 RT to 10 RT, 9 RT, 55 by 2, 27.5 RT. Oh, look at the final energy. Will it be less than or greater than? Anybody final value? This one?
$64.5.
Final intention got increased, no? Final intention got increased. So therefore, who should supply? The external agent. So UF minus UI. So this will be 4.5 RT. Heat to be supplied. Okay, on its own, so somebody should supply it, otherwise not possible. On its own, they don't undergo dissociation. I don't know how you learned in chemistry, but in physics, we have enough ideas in front of us. So look at the pressure. Earlier, calculate the pressure. Now you calculate final pressure. So let's have discussion on that also. This is the final pressure. Anybody value of this? 10, 10, 10, 20.
33 RT by V.
33 RT by V. What about initial pressure? Should be equal to 10 RT by V. So 24 RT by V. So if a gas undergoes dissociation, what will happen to pressure? Pressure of mixture after dissociation. In chemistry, you might have studied, if the gas undergoes dissociation, pressure will increase, the energy, the intensity of the gas will increase. You have in front of you a numerical itself. What will happen to rate of collisions? So you have formula, take help of that. What will happen to RMS speed of the molecules? Hydrogen, RMS speed of nitrogen and hydrogen molecules will remain same. Temperature will not change. Okay, shall I scroll down? So these are some problems related to some dissociation, pressure, energy, or all the things can be asked. Even rate of collision, total rate of collisions. Earlier, can you calculate what is the rate of collisions? No, final rate of collision, you check it. Even that will also increase. I think you have a formula, directly you can put it. So initial rate of collision, Fi, N1, Na by 2V, RT by 3m0. Will I agree this? So what is that N1? Total number of, okay, like this. Similarly, N2, Na, 2V, RT by 3m0. I think molecular masses here to substitute clearly. Yeah? This is the initial rate of collision, total number of collisions per second per unit area. Now you calculate the final also. In that case, the molecular mass, you have to be careful. I think let me write, this is something related to nitrogen. No? 28, I should write. Hydrogen, this is something 4. Finally, final rate of collision per unit area. So how many will undergo dissociation? 6. So how many will be left over?
Sir, for hydrogen, we have to write 2, no, sir.
Okay, this is 2. Yeah. Final rate of collision will not degree of freedom. I think I'll I think this was the symbol, no? What we used. Am I right? Yeah. Now, again, same thing, substitute all. So molecular mass, you have to be careful. 6 moles of nitrogen will undergo dissociation. So how much will be there? 12 will be there. So 12 Na by 2V RT by 3 into 14. 4 Na by 2V RT by 3 into 28. All the things you have to work, you have to think for everything. There is a thing. 3 moles, no? We have taken 3 moles. So 6 will come. Check it now. So compare, even this will also increase. The total number of collisions per second per unit, that will also increase here. Shall I move down? Initial rate of collision, final rate of collision. Let me add that this one.